Here we go. Interval of convergence, always the same. Take the limit as n goes to infinity of the absolute value, tossing that away, but I'm putting the n plus first term, and I'm multiplying by the reciprocal of the nth term. Okay, so let's take the time to split some of this up, right? N plus 1 quantity squared, x to the n times x to the 1, then I have 2 to the n. This guy breaks up into 2 to the n times 2 to the 1 power, right? N squared x to the n. Okay, so what do I have canceling? X to the n's go away, 2 to the n's go away. All right, what am I left with? Limit as n goes to infinity. I see 1x left over. So I'm going to pull that absolute value of x outside because I don't need it anymore. And now I'm going to be looking at what's left in here. So I see n plus 1 quantity squared and 2n squared from the denominator, right? 2n squared, n plus 1 squared. Okay, so from this limit, taking the highest powers, I get n squared from the numerator, 2n squared from the denominator, so the n squareds cancel, so the absolute value of x carries along, and from this I get 1/2. Okay, so what does this mean? So this is the answer from the ratio test. So what does the ratio test say? If it's less than 1, that's when it's absolutely convergent. Okay, so let's go solve for those x's. Solve for these x's that make this less than 1. So I'm going to say absolute value of x, multiply both sides of this by 2. This translates to between 2 and -2. So I need to do this because what do I know about the ratio test if I get equal 1? If the ratio test equals 1, I get no result. So when does the ratio test equal 1? So that I will get equal 1 if x is equal to 2 or x is equal to -2. Again, let me reiterate what I'm doing here. These two values come from the answer of absolute value of x over 2 equaling 1. Remember, when the ratio test equals 1, there's no result. So that means I need to set absolute value of x equal to 2. So that's when x is equal to 2 or -2. And it's always going to be these endpoints when I solve here. So if there's no result from the ratio test, I need to do another test. So that's what I'm going to go do. I'm going to go check x equal 2 into the original problem to see if it converges or diverges. So I have to carry everything along. N squared, I'm putting x is equal to 2, so I get 2 to the n and 2 to the n. Okay, so when you're plugging in these endpoints, you should always get lots of canceling. And look at that, I do. So what am I left with? N squared. Well, the summation of n squared with this alternating, I can see that t for d, if I take the limit of this, it does not equal 0, so therefore it diverges. So I am not going to include this endpoint of x equal 2. What about x equal -2? So it's going to be necessary for you to communicate to me, the reader, the teacher, what you're doing. So this is you saying, I'm checking x equal -2. So you put -2 in for x. Okay, so these two terms here, it's a different color here, this term and this term, because they have the same exponent, I'm allowed to multiply their insides. So -1 times -2, that gives me a 2 to the n. So that gives me the summation of n squared. So again, t for d, if I take the limit as n goes to infinity of n squared, it does not equal 0, so therefore it diverges. I don't use this endpoint either. So what is the answer? Between 2 and -2 is the domain or the interval of convergence.